This lecture module will begin the last section of the last argument on inferences and human inference abilities. We're going to shift emphasis now from general heuristics, from general inference and decision-making strategies in System 1 to this other class of strategies that also comprise System 1, namely context-dependent inference strategies. And what we'll discover, you may recall, is that these strategies differ from the general heuristics largely in terms of the scope of their applicability. These inference strategies tend to be triggered in specific contexts, in specific ways in which a problem is presented to us. And they're not triggered generally. They're not general purpose inference strategies. They aren't used outside of these contexts, even if it would be beneficial to do so. We'll look at two examples. We'll look at deontic conditional inference, and then we'll look at context-driven likelihood estimates using the Monty Hall problem. Then I'll put the material, hopefully, into perspective by discussing the errors that emerge as a result of the operation of System 1 and the difficulties that we have both detecting and compensating for these errors by characterizing them as cognitive illusions. And then we'll draw a general moral about how we should understand our native inference capacities and how we should adapt to those native inference capacities as a result of our understanding, education, and critical thinking. The first example of a hypothesized context-dependent inference strategy comes to us in the form of what's called the Wasson selection task. And the Wasson selection task is a conditional inference task. We're presented with 4 cards. The shaded sides of the cards are hidden from us. The other side reveals what's on the card. And we're asked the following question with regard to these cards. Your job is to determine which of the hidden parts of these cards you need to see to answer the following question decisively. For these cards, is it true that if there's a circle on the left, there's a circle on the right? So you might want to pause the video, take a second, try and decide which cards you absolutely have to see in order to answer that bottom question there. Let's go through and look at them now individually. If there's a circle on the left, then there's a circle on the right. So we look at the first card, A, there's a circle on the left. So if we were to pull away the covering on A and there was no circle on the right, it would violate our rule. So we have to see A. Let's now go to B. If there's a circle on the left, well, we don't know if there is, then there's a circle on the right. So if we pulled the covering away on card B and there was a circle on the left, it too would violate that rule. So we have to see B. What about C? If there's a circle on the left, then there's a circle on the right. Well, if we pulled away the covering there, it wouldn't matter whether there was a circle or not. If there was a circle, it satisfies the rule. If there isn't a circle, it doesn't violate the rule. And so as a result, we don't have to see card C. What about card D? If there's a circle on the left, then there's a circle on the right. Well, there isn't a circle on the left, so it would be impossible for card D to violate the rule by having a circle on the left and not having a circle on the right. So the correct and complete answer to this Wasson selection task is cards A and B, and only cards A and B. Now I can confidently predict that the vast majority of you did not get the correct and complete answer. And that's because studies have shown again and again since Watson's original 1966 study that the shocking result of these generic Wasson selection tasks turns out to be that less than 10% of the subjects get the correct and complete answer to the question. So this is a very difficult task for us. Let's now consider an alternative formulation of that same selection kind of task, what's called a deontic selection task. Just as before, we have 4 cards. Just as before, the shaded side hides what's on that side of the card. The other side reveals what's on that side. And we're given the following set of instructions. Each card represents a person. One side of the card tells the person's age. The other side tells what they are drinking. Imagine you're a police officer. Your job is to determine which of the hidden parts of these cards you need to see to determine if everyone is complying with the law. So here's our law. If a person is drinking alcohol in a bar, then they must be at least 21 years of age. So you might want to stop the video, think about it for a moment, decide which of these cards you absolutely have to see to determine whether everyone is complying with that law. Again, let's go through each of the cases individually. So let's start off with card A here. Card A, we see that the person is drinking a Coke, a non-alcoholic beverage. So no matter how old they are, they won't violate our law, because in order to violate our law, they have to be drinking alcohol and they have to be under 21 years of age. Let's turn our attention down to card B. This person, we're told, is drinking beer. They're drinking an alcoholic beverage. So if we were to flip over the shaded part of this card, we were to look at the contents there, and it turned out, I don't know, they're like 10. Then they violate our law. That is, they're drinking alcohol, they're under 21 years of age. So we have to see B. What about card C? Card C tells us that this person is 19 years old. So if we were to flip over the shaded side of that card, we would look at the contents there, and it says, I don't know, they're drinking a gin fizz maybe, then they would also violate our law because they're drinking alcohol, but they're under that minimum age of 21. So we need to see card C as well. What about card D? If a person is drinking alcohol in a bar, then that person must be 21 years of age or over. This person is 21 years of age, so no matter what they're drinking, they can't violate our law. So here, our correct and complete answer is B and C. Now, based on the empirical literature, I can predict with pretty high confidence that you found the second deontic selection task to be a little bit easier than you found that generic Watson selection task in the last slide. Moreover, you're much more likely to get the correct and complete answer on a deontic selection task than you are on a generic Watson selection task. Pronounced improvement in performance on deontic cases versus generic cases. And so if you're wondering, what is it about these that are different? The answer is in the very name, deontic, having to do with obligation or duty. So these conditional statements, they always relate a condition to a permission or a obligation. You're either prohibited from doing something or you are required to do something. You're either allowed to do something or you're forbidden from doing something. And this conditional is a perfect example of that. If a person is drinking alcohol, there's my condition, then that person must be 21 years of age or older. That is my obligation. So we are much, much better at the selection task when it involves permission and obligation conditionals than any other kind of conditional. And I'll elaborate on that in our next lecture module.